Okay, so welcome everybody. We are going to be talking about inequality word problems today. Everybody's favorite, right? They're actually not too bad. These are actually pretty simple problems. We're going to have to still write and solve and graph the inequality just like we've been doing. But these should be pretty simple problems. I'm just going to use X for my variable, but again, with word problems, the first thing we do with all kinds of word problems, no matter what subject in math, is to go through and just identify the important information. So we need to really understand what it's asking us to solve for, because that's what our variable is going to represent, right? But as we read through it, we can underline all the numbers, because that's going to be our important information. With inequalities, we have to look out for words like at least, right? If it says at least, that probably means it's going to be, it could be more, right? And it could be equal to as well, right? If it says more than, that means that it has to be bigger than, right? So it can't equal it. If it's less than, these should be pretty common or pretty straightforward. It would be less than, right? At most would be actually, and this is, so at least was greater than or equal to, right? Because if it's at least something, it can be more than that, right? And at most, like that's the most it can be. So you can be less than that or equal to. So those are probably the trickiest ones, at most and at least. But for the most part, it should be pretty straightforward as far as what inequality symbol you should use. And as you go through a couple of these, it'll get easier and easier to understand what it is. Okay, so let's look at an example. So let's talk about Mrs. Smith, everybody's favorite math teacher, right? Or is that Mr. Anderson? Or is that Mrs. Neverker? Or whoever your math teacher is? Okay, so let's see. Mrs. Smith goes out to eat. Well, we're not language arts teachers, although I have a language arts degree. Anyway, Mrs. Smith goes out to eat for lunch. She wants to eat less than 700 calories. So she orders a turkey sandwich with 380 calories. And she wants to eat pickles for the rest of her calories. Pickles are pretty good. Each pickle is 10 calories. How many pickles can she eat? So we're trying to figure out how many pickles she can eat and still eat less than 700 calories. So right off the bat, I know 700 has to be more than what I'm going to eat, right? Because she wants to eat less than. She can't eat exactly 700, right? So it's not going to have a line underneath of it. It has to be less than 700. Okay? I know she's going to eat 380 for her sandwich. So I know she's going to eat that much. What I don't know is how many pickles she's going to eat, right? But I know that each pickle is 10 calories. So depending on how many pickles she eats would change it, right? And remember one of the key words when we talked about the word problems with equations? That was like per or every or each, right? That's the key word that says what you're going to be multiplying your variable by. So it's going to be multiplying by each pickle, which is 10 calories. So 10x. So basically, the sandwich plus the number of pickles can't be more than 700. So that's our inequality. Not too tough, right? Then it's just a two-step equation, or inequality, right? You'd minus the 380 to each side. That gives me 220, right? Am I doing my math right? Yes. No. 320. 320 is greater than 10x. Okay? So then we would divide by 10, right? And 32 pickles would be too many. So it has to be less than 32. So how many pickles can she eat? Well, let's write that down. So it has to be less than, well, let's finish our inequality. So there's 32, 31, 33. So we'd put an open circle at 32, right? And it would go to the left. Now, this brings up an interesting discussion with word problems. When we talk about real-world situations with inequalities, we run into a situation where reality introduces a second inequality that kind of like keeps it in check. It makes it make sense. I'm not going to make you guys do that today, so you're just going to write infinities and negative infinities and stuff like that, just like we've been doing. But obviously you can't eat negative pickles, right? She didn't go in there with like a bunch of pickles she's already eaten and she's going to throw them up when she gets there, right? That would be weird. So we're going to pretend, or we're not going to think that closely about it today, just to make it easier for you guys. I can make you think more closely about it, but just to make it easier for you guys, we're going to say negative infinity to 32 in parentheses, right? I'm not going to make you, think, well, yeah, obviously reality is going to like keep that at 0. And then you'd have to like, well, how do I write that on the graph? And yeah, we'll talk about that next unit. That is a compound inequality. And that's usually what happens in the real world, are compound inequalities. But you guys aren't there yet. So we're just going to focus on this. So really, she can eat less than 32 is our answer, right? Reality, like that would be like 31 pickles, right? She could eat 31 pickles and be done. Okay. So let's try another one. Let's talk about Mrs. Lloyd. So Mrs. Lloyd is going on a trip. Her flight costs $230, and her hotel dollars is $80 each night. So I can already kind of tell what I'm going to be multiplying by, right? She wants to spend at least, so at least means she's going to spend more than that, right? Or wants to spend that much or more. At least $600 on the trip. So how many nights would she have to stay until she has met her minimum amount to spend? She's got money burning a hole in her pockets, evidently. She wants to spend it. So $600 is the amount she wants to spend at least, right? So this number has to be less than or equal to what she spends. So the alligator is going to eat the other side this time. That needs to be the lesser or equal to number. Okay? Now, what do we know? Her flight costs $230. That's a one-time fee, right? We're not going to spend that again. And then her hotel depends on how many nights she stays there, right? So that's where the each comes in, because we're trying to figure out how many nights she would have to stay to meet her minimum amount she wants to spend. So each night is $80. So depending on how many nights she goes, that will tell us how many times it'll take to get to 600. So two-step inequality again, right? We'd minus 230 to each side, and we would get 370 is less than or equal to 80x, and then we would divide by 80, and that's going to give me a decimal, which is perfectly okay, especially with inequalities, right? So 370 divided by 80, because we're talking about ranges of numbers anyway. All these answers technically include lots of decimals. 370 divided by 80 is 4.625. So 4.6, I'm just going to round it. It would be less than or equal to X. So, the reality here is if she only stays, the hotel isn't going to, charge her a 0.6 of a night stay, right? So, really, if we think about this in terms of reality, in order to spend $600, she's going to have to stay at least 5 nights, right? It's got to be at least 5 nights. If she stays 4 nights, she hasn't spent that money yet. If she stays 5 nights, then she would have spent it. Now, if you put this answer in, I would accept that. That's obviously an answer that's acceptable on like the Canvas quiz or whatever. But this is the more acceptable answer, right? That shows that you thought about it and applied some critical thinking, right? She has to spend at least 5 nights there. So when we graph it, 4, 5, 6, it's going to have a closed circle, and it's going to go to the right because it's eating the variable, right? Now, that makes sense, right? Because she wants to spend at least $600, but could she stay longer? Yeah, she could spend more money, right? She could stay at that hotel forever, depending on if she has enough money or not, right? So she could stay there for 5 nights, or she could stay there for infinite nights. Or until, yeah. I'm not going to say that. Okay, and that would be your answers. Okay, word problems, not too tough, right? Again, probably the thing that students struggle with the most is what type of symbol to use. And that's why these terms up here are important. Is this too bright? Can you guys see better? I think that helps a little bit. Okay. So at least is going to be a greater than or equal to. More than is obviously more. Less than is less. At most is actually a less than or equal to. Let's try another one. So let's try talking about Mrs. Waite, our lovely principal. So Mrs. Waite wants to say something positive to more than 50 students a day. Okay? If she has already said something positive to 23 students, how many students will she say something positive to? So how many students will she say something positive to? Well, let's think about it. So she wants to say something positive to more than 50 students. So that means 50 students, or the 50 has to be less than the number of students she actually says something positive to, right? So the alligator is going to eat the other side. She has already said something positive to 23. So I need to figure out how many students she still needs to say something positive to, right? So that is going to be my X. There's nothing multiplying it. It's just something she needs to do. This is a one-step equation. So she's already said something positive to 23, so we're going to take that away from what she has to do, right? And she's going to be left with at least 27 students. Or she has to say it to more than 27 students. If she says it to exactly 27 students, it's not enough, right? It has to be more than 27 students. So 26, 27, 28, open circle. It needs to be not 27, but 28 going forward, right? And interval notation would be 27 to infinity, but again, since it can't equal 27, you put a parenthesis on it to show that technically it needs to be more than 27. It needs to be like 28. She could say like half a compliment. Or something. Okay. Anything else I want to do? Hey, let's do Mr. Noise. Let's talk about Mr. No Yes. Mr. No Yes. Mr. No Yes likes to go into the hall and do a little dance at least 5 times a day. If he has already danced in the hall twice, how many more times is Mr. Noise going to do a little dance? So this is a really simple one, but let's talk about it. So he wants to do it at least. So at least means it's going to be equal to, right? At least 5 times a day. So it needs to be more than 5 times a day. 5 times is the minimum that he's going to do it. So it's going to eat the other direction, but it's at least 5, so it can equal 5. As long as he's done at least 5 times, he's good. He's already done it twice, so how many more times does he have to do it? Well, that's what our x is going to be, so plus x. So we take how many times he's done a little dance, and that would be 3 remaining, right? So he needs to do 3 more little dances in the hallway before he's good. Now, could he do 4 more dances? Sure. Could he do 10 more dances? Sure. Could he do 1,000 more dances? Well, that's a lot of little dances. But sure. I think he'd probably be dancing all day. But that's perfectly possible, right? So on our number line, when we graph it, we'd have a closed circle, and it would go to the right. And it would be 3 to infinity. And since it's a closed circle, be a bracket. And that'd be your answers. Okay. If you have any questions, please ask your teachers. We're here to help. We want to help. You just need to ask us. So I'll see you guys out there.